yellow fever. What's the common denominator? The mosquitoes. When don't have power, don't have electricity, how is technology enhanced learning going to help me if I can't turn on my mobile phone or can't turn on my laptop? What started as an idea to stop the mosquito menace evolved into a product for a new dimension solving these two problems. This idea germinated in my mind last summer when I was at my grandma's place in a remote part of South India. Of course, no power, no electricity, no running water. And the mosquitoes constantly annoyed me. First year, I began thinking, why is the current techniques working? Why don't I think of something new that solves and is particularly suited to this particular situation of no power, no electricity? So, ladies and gentlemen, I present to you IRIS, portable, multi-pronged mosquito repellent. I know it sounds smug, but does work. So let's have a look at the current technique. The repellent coil, aerosol, and electric repellent have a common chemical known as DET, D-W-E-T. It's proven to be harmful to pregnant ladies and kids. And for the suit, so on and so forth, almost every other technique has a flaw or other, be it limited range, capability, or requirement of power. For example, the swatter requires you to find a mosquito and then swat it. Agreed, Indians are cricket crazy. But we can't be playing cricket all night long, can we? We need to sleep. So, let's have a look at a foe, the mosquito. Like a smart bomb, key on its target, it's called area sensor from thermal order to CO2 sensor to locate and track its target, that being us. In military, there's a strategy called tactics of avoidance. That is, why fight a battle when you can truly avoid it? Logic. So why fight mosquitoes when you can avoid them altogether? So here I present you two principles upon which my project is based. The first being thermal image masking. If you can mask the heat signature from a body, from the human body, mosquitoes can't see through. If they can't see through, they won't be able to get to us. And if they aren't able to get to us, they can't feed on us. The second technique being ultrasonic distress zone. The mosquitoes which bite us are female mosquitoes. They're two pregnant female mosquitoes. And they have a unique instinct. They tend to avoid male mosquitoes for obvious reason. And dragonfly, the arch enemy. And each of these mosquito and almost every other insect produce ultrasonic signal when they flutter their wing, specific to the characteristic, species, and type. And this signal can be duplicated and replicated using the sound synthesizer and a woofer. And that is what is being done here in this particular device. The ultrasound emanating unit mimics the male mosquito and dragonfly to thwart the mosquito. To add an additional layer of defense, we have an array of interlaced infrared diode to have a thermal image masking. And these two units combined together gives me a conventional socket plug-in device that can be used as normal power utility. But the problem was altogether different. It was the power, electricity. So what we did is, we in the sense, me and my team, we retrofitted the whole system with a crank mechanism. The crank has a mechanical device for us to power it, a dynamo to convert mechanical energy to electrical energy, and a battery to store the electrical energy. So it can serve as backup power unit during the power shutdown. So cranking it up for 10 minutes, according to calculation, which shows that the unit saves on 2 hours of energy, I can run the whole system overnight. Now, that's truly amazing. Then we begin thinking, right? I have the crank mechanism, I have the energy storage mechanism, I have all the integrated unit. So why not take it a step further? Our fourth step of innovation. What if I can put a lighting unit on top of it to serve as backup lighting source during power cut so that I can read peacefully? And side by side, what if I can run my repeller unit too? And why stop with that? Why not push the boundary further? What if I can add a mobile charging unit? If possible, even a laptop charging unit. And run this whole system in a concrete, synchronized manner. To have an integrated device, they can serve my whole purpose. Now, that is innovation. But it all comes down to cost, doesn't it? The basic unit, which comes down to few PCBs and microcontroller, costs about $380. Well, that's fine enough. But the advanced upgraded unit costs about $1,270. The major cost factor being from the battery. Of course, if we can mass produce the system, we presume we can bring the cost down by $200. The integrated product, the flagship product, is push the cost further by $600. So we thought the affordability and feasibility of the system is a problem. So what we brought in is a social entrepreneurship model, a business model based on social entrepreneurship. So we have models ranging from triple P to retail subsidized price. Thank you, TEDxCoimbatore for TEDxChange for the opportunity. Thank you all. Hello, ma'am.
Wow, Saranya Raj, that is a true innovation. I remember so many nights with the mosquitoes, so that's a great innovation. And tell us how this is different from this dragonfly scares mosquitoes, right?
Yeah, of course, ma'am.
Yeah,
Yes.
so I heard that the larva of the dragonflies actually eat the larva of the mosquito. It starts very young. The rivalry starts very young. So is there other technologies, other products using this technology? How is this different in yours?
Yeah, that's a very good question. Actually, there's a particular technology that uses dragonfly ultrasound signal to throw the mosquito. The problem with that is the signal tends to be too audible. It kind of creates a disturbance, ambient noise. And of course, I failed to mention two particular points. Infrared rays and ultrasonic sound are invisible to human environment. They don't disturb our ambience. So we can rest in peace. The system present today basically uses just one system, that is ultrasonic system. So what we did is we combined two layers of defense, that is 1 plus 1 equal to 1. That is, makes sense to me as an Indian. A single system that can serve the dual purpose, at the same time have additional power unit.
So it combines both technologies.
Of
Great. You've been on National Geographic Channel, CNN, IBN, and now on TEDx stage. Tell us a little bit about yourself. What else do you do?
What else do I? Okay, fine.
Why did you go on National Geographic?
Okay, National Geographic Channel I went on last semester because I had a project based on a solar power, a different kind of solar power harvesting technology that can be used by anybody, even domestic area. Now that I've been commercializing right now with the help of funding from IIM Bangalore. And of course, CNN IBN, that was a talent competition for the bright minds of all India. Yep. Mostly people from IIT and IIM came there, and I was the one to represent the whole Tamil Nadu there.
We're so proud of you. How do you see this mosquito thing affecting the whole world? How can this invention of yours revolutionize?
Okay, I have to say this. I'm not patenting this invention. Even if I'm patenting, I'm giving it for general public licensing. Seriously. What we try to do here is a social entrepreneurship. So I take this platform to call upon all the venture capitalists and who can fund us so that we can give the system, if not for free, for at least subsidized cost to everybody. Let's have a common reach. Let's go for social cause.